2, 3, and 5. Starting with number 1, you had to simplify. Find your like terms. The ones with K's are like terms. The ones without K's are like terms, but to themselves. So negative 15 plus 2 would give us negative 13K. Negative 1 plus 12 would be a positive 11. That would be your final answer. Number 2 goes back to when we were solving literal equations. So we have to get W by itself. The easiest way to do that is to subtract 2L on both sides. So P minus 2L equals 2W. And then divide both sides by 2. P minus 2L all over 2 equals W. Or, if you wanted to simplify, you would have to divide everything by 2. So P over 2 minus L equals W. Either of those is okay. Questions on 1 or 2? For number 3, we had to distribute and then combine like terms. We have negative 12x minus 6 minus 2x plus 6 plus 15x minus 20. And then find all your x's. Negative 12 minus 2 would be negative 14. Negative 14 plus 15 would be a positive 1x. And then add up all your constants. These would cancel each other out, just leaving minus 20. So x minus 20 was our final answer for that one. Questions on that one? And then 5, we had to solve this. I'm going to rewrite this. For b, if we multiply both sides by 2b minus 8, we can get it out of the denominator. These would cancel. And then this would become 2b minus 8.
Oh, so we don't multiply those.
You could do that. You would end up with the same thing. So I'll come back and do that. Because here we have to add 8 to both sides and then divide both sides by 2. But here, we would still need to get 3 back on the other side. And the process is the same. So you would still end up with the same answer either way. Other questions on that? Before we start our notes, everyone look at your calendar. A couple things I want you to notice. 1, there's only one flex day, as we voted on last 2 classes ago. We did our flex day earlier than we were going to because it was going to be today. And then our next flex day is November 22nd, which is right before Thanksgiving break. I know that some of you may or may not be here, so if you are not here that day, you miss your flex day. So you'll need to come before after school to get stuff done prior to that. And then this is really important, so if you have both headphones in, take one of them out. I really need to make sure you're listening. If you're on your phone, I need you to have your eyes up here. This quarter ends in January. we just took this test at the end of October. You should not be retaking this test in January. You should be retaking this test as soon as possible. You have plenty of time to get the retake work done, to retake way before then. So I should not see your faces in my office hours the last week of the quarter trying to retake this test. Does everyone understand what I just said? So on that topic of retakes, the test correction is the same. Doing your Khan Academy is the same. Additional practice, if you score below a C, instead of me giving you papers and then we losing on both ends, we're just going to end that game. All additional practice moving forward will be on Delta Math. So if you've not signed up for that already, it's on the board, it's on Canvas. You can use that hot pink rectangle and join using that code. If you need to do additional practice, you will need to do that. And then you can just take a picture of your completed, whatever your completed Khan Academies, and then once I check over your test corrections, that as well, and upload it to the test mistakes. Any questions on any of that? Okay. Also on your calendar, be aware of the Khan Academy quiz dates. There are only 2 really, the 11th and the 18th, so make sure you get those done by then. And then our quiz and test is right before our flex day. That is purposely planned. That way you can finish your tests. And if you need to retake or do retake work on the 22nd, you will have that time. Any questions about the calendar, retakes, anything like that? So those of you that said you wanted to retake, I should start to see you this week, next week, before, after school to come get your test corrections, additional practice, Khan Academy, if you need help, all of those things done and retake as soon as possible. Moving on. So everyone should have notes that look like this. So previously, we've been talking about different types of linear equation solving, things like that. Now we're going to be talking about systems where there is more than one equation. So we're going to talk about the different ways to solve said equations and things like that. Before we jump into the how, we're going to talk about some other things. Like, if I were given this this system of equations, let's say I solved it, however, and I got this as a solution, how would I know that is my solution? How would I know that it works? How could I check myself? Right? I could do that. Besides that, how else could I do that? Yes. So anytime you solve it by graphing, by algebraic, whatever, we're going to put this back in to see does it work, where you should be doing this. As a good check, did I do this correctly? So we have to do this for both equations, because if one works and the other doesn't, then it's not a solution to both. So this would be 2 equals negative 1/3 times 3 plus 3. And then we're going to solve this, see if, like with regular equations, if we get a true statement, then it works. If we don't, then it doesn't. So that first one works, but just because the first one works doesn't mean we can assume that the second one works. We have to still double check. So do the same thing, put 2 and 3 into the second equation. And in this case, they both work. So because they both work, I can say this is the solution to this equation, to these equations. Do we have any questions on that? We're going to do one more. And then I'm going to let you try a couple. We're going to do 3. Notice that 3 looks different than the ones we just did, but the process is going to be the same. We're still going to put this in for x and y. We're not going to solve this or anything. Rearrange is what I mean. So I would put these in for x and y exactly how it's written. So this would become 4. This would become a positive 8. And 4 plus 8 is 12. And then I'm going to do the next one. But in this case, we're going to get 12. This is going to become a positive 4. And this becomes 16, which does not equal negative 4. So one works, one doesn't. But because one does not work, this is not the solution. So somewhere, maybe when we were solving this, we missed a negative or something, so we got the wrong answer. So we have to go back and double check our work. Okay. Questions on 3? I want you to try 2 and 4, and I'll give you a couple minutes to do that, and then we'll come back and talk about it. Did we find that 2 did or did not work?
It didn't work.
Did not work. Does anyone need to see that one? Okay. And then for number 4, did that solution work or not work? That did work. Did anyone need to see that one? So as you start to solve these, check your answers, double check, is this the actual solution or did I do something wrong? One of the first ways to solve systems is by graphing. When we actually do that, you'll get graphs, they will intersect somewhere, and wherever they intersect will be the solution. Find where they intersect or cross. -2, -1 would be our answer. So what would the answer to 6 be? -1, -1. The answer to 7. 3, -1. And the answer to 8. So as long as they intersect in their graph correctly, you can find the intersection point, and that would be your solution. We're going to skip this next page and move on to this one. And then I'm going to have you start filling this in. So the definition of a system of equations are 2 or more equations with the same variables. So in here, we're just going to do 2 equations. I think in algebra 2, you move on to 3. It's a little hectic. The solution to a system graphically is the point xy where the 2 lines intersect or cross or meet. Algebraically is the point xy that makes both equations true. So we just did both of those things, found graphically where the lines intersect, and algebraically what makes the equations true. And I'm going to have you draw this diagram. If you want to use two different colors like they are using, I would suggest two different writing utensils, pen, pencil. I have colored pencils and the colorful trays. If we have intersecting lines, any way they intersect, you're going to have one solution, and we're going to write that solution as an ordered pair, x, comma, y, in parentheses. This middle one goes back to our last unit when we talked about parallel and perpendicular lines. If we have parallel lines that never touch each other, they are never going to intersect. So we will never have a solution. And then this last one, if they happen to be the exact same line, they're going to lie on top of each other. And because of that, every single point is going to intersect. So there'll be infinitely many solutions. See you Friday. Anyone still writing this top part? There are 3 steps to solving a system by graphing. 1, rewrite the equations in slope-intercept form if they're not already. 2, graph the lines. And then 3, identify the solution. If there's no solution, if there's many, you'll be able to see it once you graph it. I didn't mean to do that. That's okay. Anyone still need this? So then let's do number 1. So I'm going to graph these in 2 different colors. You do not need to do that, but if it helps you see them clearly or better, I would suggest doing that. Again, I have colored pencils and a colorful tray. So this goes back to when we were graphing. We have to remember how to graph. Start at your y-intercept, -8. This is a 10 by 10 graph, just so you know. And then our slope is 1, the number in front of x. It is positive, so we're going to go up 1 to the right 1 as many times as we can, fill up your graph. If you need rulers, they are also in the colorful cart tray. And then you're going to do the same and go the opposite way. Down one, left one, as many times as possible. Connect all of your points. And make sure your lines have arrows. And then we're going to do the other one. So this one we're going to start at +1. Our slope is -2, so we're going to go up 2 to the left 1 as many times as possible. And down 2 to the right 1 as many times as possible. So then what would be the solution of this graph? Are you raising your hand? Yes, they are intersecting, so you're going to have one solution. What is that solution?
3 and
So if you need to like circle where they intersect, you can, so that it helps you see it more thoroughly. But that is how we solve a systems of equations by graphing. Do we have any questions on that process? How we graph those lines? How we got that answer? Anything like that? Pretty simple. Okay, we're going to do one on the next page. Number 4. I meant to say this before we did this, before we did the last one, but those were already in slope-intercept form, so we didn't have to like change anything. So we basically skipped to step 2. This one, though, there is an equation that we have to change before we can graph it. I'm going to rewrite it so I have more space. And then we need to get this back in slope-intercept form. So as we did way back when, subtract x to the other side. And then I'm switching the order of x and the number so that it starts to look like y equals mx plus b. And then to get y by itself, divide everything by 2. So this would be y equals -1/2 x plus 2. Look at the equations. What do you notice? They're equal, they're exactly the same. So that means without even graphing this, because they are the same line, I know this is going to be infinitely many solutions, or IMS, either or. Even if you find the solution, you still have to graph it, because it is solving by graphing. You don't, however, have to draw both lines. So I would say draw one, and then I'll show you how you can say that you drew both. So start at +2. Your slope is -1/2, so go up 1, left 2 as many times as possible. Once you have one line, to show that there are two just drawn on top of another, well, not that, I would just at the ends draw like a second set of arrows. That would show me that there's one line drawn on top of the other. Other ways you could show that is if you had two different colors and drew both lines on top of each other. Or if you drew one in like a pencil, pen, color pencil, and then highlighted over top of it, that would also show both. Just somehow I need to know that you know that there are two lines there, not just one. Questions on that one? So now I want you to look at all of the other problems on all of the pages. Find any problems you want to see, go over, have questions about, maybe aren't sure how to start, anything like that. 8. 6. Yes. 5. 7. On the same page. Yes. 7 we're actually going to do a different way, and then 5 and 8 are very similar, so we probably won't do both of them, and then we could do 6. Sloan, did you make a pass already? Okay. Let me know when the pass goes through. So I think we're going to do 6, 7, and 8, and then 5, I'll just refer back to 8. So starting with 6, 1 is in slope-intercept form already, so you can graph that one. Your slope is 1, so you go up 1 over 1 as many times as possible, down the left 1 as many times as possible. With your graph, so before when you did your graphs, if your points were there but your line was a little off, it was okay for the most part. If you don't draw your lines and points exactly, you could cross at the wrong point, so be very careful. Draw your lines as accurate as possible. Then we would need to solve the second one. Subtract x on both sides. And divide all sides by -1. Divide everything by -1. So y equals a positive x minus 2. Your slope is positive 1, so just like the last. Up 1, right 1, down 1, left 1. As many times as possible and fill up your graph. What is the solution to this? They are parallel, but that's not the solution. So there's no solution, correct. So if you just write that they're parallel, I'm going to say, what does that mean? If you write the 0 with a line through it. Because that could mean that 0 is a solution. We don't want that. Yes, I know. You can write out the words no solution. You can write NS. Any of those, as long as you don't write just 0. None is fine. For 8 and 5, you have a y equals and an x equals. So you need your 4 thus. So if you thought that was going away, it is not anytime soon. So for x equals -2, that will be a vertical line. So find on your x-axis when x is -2 and draw a vertical line. And then we would need to solve this equation. Move x, the x term to the other side. And divide everything by -2. So y equals +3/2 x plus 9. What's nice about these type of problems is whatever x equals or y equals, that's going to be part of your solution. Unless you get like 2x equals or x equals and a y equals. So this would start at 9. I can't go up, so I can go down 3, left 2, as many times as possible. Then your solution would be what? -2. It might be 6, 7, yeah. 1, 2, 3, 4, 5, 6. 7, if you were doing by hand, you would just need to solve both of them and then graph both of them and then see the solutions. I'm going to show you 2 things. One, how to double check yourself with a calculator, and then one, how to double check yourself with Desmos. If you don't have your calculator, go grab that. And then if you go get your calculator, or if you already have it, reset it, second plus 7, 1, 2. And we're going to do number 2 from this page. So the previous page. Second plus 7, 1, 2. So on your calculator, you are going to go into y equals, because we need to graph these, but we need to put the equations in first. So in y equals at the top, we're going to put in both of our equations from number 2. Alpha y equals gives you your fraction. Make sure you're using the negative, not the minus, for the second. Y equals to start, and then put in your 2 equations.
This color punch you get at
This one right here, next to alpha. Alpha y equals. Anyone else need help getting those equations in? Yes, which step are you at? Alpha y equals, just y equals. Alpha y equals to get your fraction. Anyone else need help getting there? Y equals. Put those for number 2. Once those two equations are in, we're going to go into graph. And you should be able to see that they intersect. But I don't know about you, you could count this, but looking at the calculator screen is difficult for me to count the numbers. So instead of counting, we're going to go into second trace. And what do we think we're going to go into? Five intersect, yep. So go into 5. And then it's going to ask you for first curve. That's just talking about the first equation, the first line. So as long as your cursor is on one of them, hit enter. And then it'll say second curve. As long as your cursor is on the second one, hit enter. And then it'll ask, do you want to guess? And we don't, so hit enter again. And it'll tell you what that intersection is. So this is a good way to check yourself without doing it algebraically, that the equations you have, you got the right intersection when you graphed it. Also, if you solve the equations and put them in, to double check that your equations got the right intersection. Now, I'm not going to graph this up here, but just because you double check yourself in the calculator doesn't mean you don't have to do the graphs. You do still have to do the graphs, because it is solving by graphing. Questions on calculator? How we check ourselves in the calculator? Okay. And then if you're at home and don't have access to these calculators and want to double check yourself, so now I'm going to do 7. If you have the Desmos app or Desmos on your phone, go ahead and pull that up. What's nice about Desmos is I don't have to do anything before I put the things in here, the equations. I can just put it directly in. Yeah. So I'm going to type the equations in exactly as I see them for number 7. 3x minus 5y equals negative 35. And 2x plus y equals negative 6. It will graph those for you. And then if you click on the middle of where they intersect, it'll show you the intersection point. So that'll be good when you're practicing at home, as you should be practicing at home. Any Desmos questions, calculator questions? Excuse me, or anything else we need to see, go over, have questions about. Alright. So for the remainder of class, you guys have time to practice. You can do one of 3 things. You can practice anything on the notes, anything from the notes. You can practice the 2 Khan Academy quizzes that are due next week. I would say use Desmos, or I have a scavenger hunt around the room if you want to use that. But come see me for that. Oh, okay. You got 2. You got 2 of the same thing, but they both say the same. So I'm gonna take one. Okay. So whatever practice.